Welcome to this video on energy resources. We will cover where our energy comes from, how it is generated, and the key trade-offs involved in choosing between different power sources. Energy resources are stores or flows of energy we harness for daily needs. Studying them is crucial for understanding the impact of our choices on cost, reliability, and the environment. Most electricity is produced through energy transfers. A primary source, like wind or fuel, drives a turbine, which spins a generator to create electrical energy. We classify energy resources as either non-renewable, which will eventually run out, or renewable, which can be naturally replenished on a human timescale. Fossil fuels, including coal, oil, and natural gas, are non-renewable. Formed over millions of years, they remain the most widely used energy source globally for powering our homes and industries. In traditional power stations, fossil fuels are burned to heat water. This produces steam, which drives a turbine connected to a generator to create electricity. Fossil fuels offer reliable, high-density energy with established infrastructure. However, they are non-renewable, and their use significantly contributes to climate change and environmental damage. Burning fossil fuels releases carbon dioxide, a greenhouse gas that has been stored for millions of years. This enhances the natural greenhouse effect, driving global climate change. The greenhouse effect works by trapping heat in our atmosphere. This leads to rising temperatures, melting ice, and more extreme weather, with fossil fuel use being the primary human contributor. Nuclear power is another non-renewable resource. Unlike fossil fuels, it does not use combustion, but instead relies on nuclear fission to release massive amounts of energy from a small amount of fuel. In a nuclear reactor, uranium nuclei are split during fission. This releases thermal energy, which turns water into steam to drive turbines, just like in a fossil fuel plant. Nuclear power is a reliable, low-carbon energy source. However, it involves significant challenges, including radioactive waste management, high costs, and the risk of serious accidents. Turning our focus to renewables, these resources replenish naturally and are vital for building a sustainable, long-term energy future. There are many renewable options, including wind, solar, hydroelectric, tidal, geothermal, and biofuels. Each uses unique processes to convert natural energy flows into usable power. Wind energy utilizes the kinetic energy of air to spin turbines. Wind farms can be placed onshore or offshore, where stronger winds often provide more consistent energy. Wind energy is a clean, renewable source that generates electricity without direct greenhouse gas emissions. While the fuel is free, it relies on weather, and building turbines involves significant initial costs and landscape impacts. Solar energy is one of the fastest-growing power sources. It works by capturing sunlight using photovoltaic cells or heating water with thermal panels, providing a sustainable, renewable option for generating power. Key facts about solar energy: it's a practically unlimited resource. While panels have a carbon cost to manufacture, they produce no emissions during operation. Reliability depends on sunlight, making it best for rooftop or sunny region installations. Hydroelectric power stations harness the energy of water stored at height. By releasing this water to flow through turbines, we convert gravitational potential energy into reliable, renewable electricity. Hydroelectric power is highly reliable because water can be released on demand. While it has a long lifespan and zero operational emissions, it requires specific geography and can have significant environmental impacts due to flooding. Tidal power captures the kinetic energy created by the movement of ocean tides. As the moon and sun pull on our oceans, this consistent, rhythmic flow drives turbines to generate electricity. Tidal power is incredibly predictable because tidal cycles are known years in advance. It produces zero operational emissions, though it is limited to specific coastal areas and faces challenges like high construction costs and ecosystem disruption. Geothermal energy taps into the intense heat stored deep within the earth. In volcanic regions, we can channel steam or hot water from underground directly to drive power-generating turbines. Geothermal is a reliable, low-emission source of power. However, it is geographically limited to volcanic areas, and the initial costs for drilling and setup can be quite high. Biofuels are derived from plant matter or animal waste. Because we can regrow these resources, they are considered renewable. They allow us to store chemical energy and release it through combustion when needed. Biofuels offer flexibility, as they can often be used in existing engines. While they are theoretically carbon neutral, they still release carbon when burned and require large amounts of land that could otherwise be used for food crops. When we compare environmental impacts, most renewables produce far fewer greenhouse gases over their lifetime than fossil fuels. Biofuels are unique in that they reabsorb carbon during growth, aiding in a more neutral cycle. A major challenge for many renewable energy sources is intermittency. Since we cannot always control when the wind blows or the sun shines, Maintaining a consistent, reliable electricity supply requires careful grid management. Reliability varies by source. Solar and wind are weather-dependent, whereas biofuels provide better control. Hydro, tidal, and geothermal stand out as the most consistent and predictable renewable options for a stable grid. Ultimately, selecting the right energy mix requires balancing these factors: reliability, environmental impact, and cost, to create a sustainable, secure, and efficient energy future. When deciding on energy sources, we must consider several factors. These include construction and maintenance costs, the reliability of the supply, especially during peak demand, and the overall environmental footprint, such as greenhouse gas emissions and land use. Beyond technical performance, energy choices are influenced by social and political factors like government subsidies and public support. Practical constraints, such as available geography, existing infrastructure, and the speed at which we can build new projects, are also vital considerations. To summarize, non-renewables like fossil fuels and nuclear are highly reliable and offer high energy output, but they have finite supplies or environmental costs. Renewables are sustainable and cleaner, though they are often dependent on natural, variable conditions. For your exams, keep these tips in mind. Define your terms precisely, always note that renewables are often less reliable than fossil fuels, and structure your evaluations by comparing cost, reliability, and impact. Remember, even renewable biofuels can produce CO2 when burned. Use this checklist to test your knowledge. If you can define the terms, describe the energy sources, and compare them effectively, you are well prepared for your exams. Good luck!